Wait, okay, it's working. Zero mic here. Just like no. I got an email. 1 second, guys. I gotta check this one out. What is it? So, oh, okay. Whatever the fuck, whatever, bro. Yeah. So, what I'm gonna do today is that I'm gonna try to understand what is going on in differentiation scientifically using a fucking book. Right, so we're gonna go through each page and try to understand what is going on again, like I told you. So, primarily, the concept of sequence and limits. Differential calculus. We're starting with the differential calculus, guys. So, first of all, we are gonna explore the sequence and limits. The concept of sequence. As a primary example, consider the fraction. Consider the fraction 1 over n. By giving n the values of the natural number 1, 2, 3, 4, 5. Successfully, we obtain the following sequence. So if we started with 1, it's going to be 1 half 1 over 3, 1 over 4, 1 over 5. Okay, that's so fucking awesome. These values are illustrated graphically on 5.1. Okay, 1 half. Okay, sounds well, sounds good. Looks good too. Supplementary information. The online version contains supplementary materials. Let me check this one out. I would like actually to go there to this link to see what does it talk about now. And the download differential calculus. Holy shit! There is a whole fucking book for that. That is scary. Differential calculus. Holy shit! Holy shit! Oh, onto the same book. Same book. Never mind. Supplementary information. In this example, 1 over n defined the form of the sequence, and to n we assigned the values of the natural numbers. The functional representation of the terms of a sequence is usually denoted by an. So that sequence becomes an. So yeah, okay, understandable. So here, he basically says that the n is the number that we are putting in this fucking function. All right. So and we represent it by saying like the function a1. So 1 is gonna be put in a whatever was like the variable. This can be abbreviated thus an. An is the nth term of the sequence, sometimes referred to as the general term. Example: let an be given by an equals to 1 over n multiplied by n plus 1. This given, okay, understandable. So it's gonna be 1 over the following sequence. 1 over 1, and this is gonna be 2 because it's 1 plus 1. Here's gonna 2 plus 1, which is 3. Here's gonna be 3 plus 1, which is 4. All right, so it's gonna be 4. Sorry, I meant to circle this. Example: let an be given by an equals to this. So this is basically gonna be an over 1. Right, it's gonna be negative 1 over 2, right? Oh, okay, there's multiplied by here, so it's gonna be multiplied by 2, so it's gonna be negative 1 all over 3 multiplied by 3, which is gonna give us 2, negative 3, 4, negative 5, and so on. Example: let an be given by a multiplied by q over n, where a and q are real numbers. By giving n the values 0, 1, 2, 3, the following sequence is obtained: aq power 1, aq power 2, aq power 3. Sure, 0 power 1, by the way, but it's not visible. This type of sequence is called geometric sequence. It's a geometric progression, GB, and nq is known as the common ratio. Sounds so good. As a sequence may be defined, maybe finite or infinite. In the case of finite sequence, the range of n is limited, i.e. the sequence terminates after a certain number of terms and infinite. So limit of sequence is going to be like the introduction to the functions, where there's an actual limit to the function, or there is a domain, a specific domain and a specific range. Okay, let's go to 5.1.2, limit of a sequence. Limit of a sequence. Consider the sequence formed by an equals to 1 over n. If we let n grow indefinitely, then it follows. What is going on? Alright, let me do that. Then it follows 1 over n coverage. Hold on, let me open the camera because I would like to be seen. Because this makes me more like. A little bit for. Let me fix my hair a little bit. Okay, it's decent. It's okay. I don't mind it. Anywho, let's get going. Where we? Where were we? Where were we? Would like to see the stream a little bit here. Okay, so there is nothing that you cannot see actually. Okay, sounds good. Looks good. Consider the sequence formed by an. An equals to 1 over n. If we let n grow indefinitely, it will follow. It follows that 1 over n coverage to 0 or tends to 0. So it's gonna be go to 0 because it keeps getting smaller. So it keeps going slower as the n keeps going to infinity. So limit is, so what's the limit? The limit is gonna be n to infinity. If this becomes infinity, it's gonna be 0. If like infinity is an actual number. 0 denotes the limiting value of 1 over n as n tends to infinity. Such a sequence is referred to a null sequence. Null sequence. That's a good name. But it's gonna be null, I guess. The sequence whose general term is an equals to 1 plus 1 over n. On the other hand, coverage will to the value 1 as n increased indefinitely in general limiting value. That's because like 1 plus 1 over n, and if n goes to infinity, this is gonna be 0. So this is gonna be 0. So it's gonna be equals to 1. So this is like the end value, the end result when n is going to infinity. Definition of a sequence whose general term is an coverage towards the finite value g as n. Again, if a sequence whose general term is an coverage towards finite value g as n goes to infinity, then g is called the limit of the sequence. G is called the limit of the sequence. This is written as limit n to infinity an g. Let me take a sip of water. I'd like to check something out real quick. Let it go. Let it go. I need to look in. All right. I'm sorry. I'm sorry, guys. I'm sorry. How many minutes did I waste? How many minutes did I fucking waste? I need to go to the bathroom a little bit. But anywho, lock the fuck in, boy. A precise mathematical definition is as follows. The sequence formed by the general term an is said to converge towards the constant value g if any pre-assigned positive number. What the fuck is this? Let's say it's e. However small, positive number, mathematical definition as follows. The sequence formed by general term an is said to converge towards the constant value g. Okay, okay. If for any pre-assigned positive number e, however small, it is possible to find a positive integer m such that an minus g is smaller than e for all n. If a sequence I don't understand this word. I'm not gonna even like try to understand it. If a sequence converge towards the value g is said to be okay, now I get it a little bit. A sequence that does not converge is said to be divergent. The following examples are given without proof to illustrate convergent and divergent sequences. Convergent sequences, the sequence defined as an has a limit value of 1 as n goes to infinity. This is because the number 1 is the denominator becomes less and less important as n becomes larger. The sequence illustrated in the following. So like the difference is bigger, and then the difference is less, and gonna go like a straight line. So example, the sequence defined as 2 plus negative 1 over 2 and 2 plus negative 1 over 2 all over n has the limiting value 2 as n goes to infinity, because if that's 2, if that becomes to 0, this is going to be equals to 0, I guess, or 1. I'm not really sure if that becomes infinity. It's going to be infinite number, and infinite number is going to be basically like something. It's gonna go like for it's gonna be 0, I guess, or something like that. It's equal to illustrate. It's gonna be 2. It increases, but the increasement is not gonna be super. No, it's actually gonna be decreasing. Yeah, here. So it's gonna be decreasing, so it's not gonna be super. It's something like this. It's something like this. It's like yeah. Example: a sequence of great significance is defined by a equals to a plus an equals to 1 plus 1 over n over n. This is the sequence that have limiting value, which denoted by the letter a. After Euler who discovered it. Euler number E. Limit. A sequence of great significance is defined by a equals to 1. So that's like an equals to 1 over plus. Okay, it's not like this. 1 plus 1 over n, 1 plus 1 over n, all bar n. So basically, like definitions. Okay, so this is a sequence that has a limiting value, which is denoted by the letter E, named after Euler who discovered it. Euler, this is a sequence that has limiting value that is denoted. So the limit for this number, like the limit is gonna be E. Whatever the fuck is E is this fucking number, and like the limiting value, the limit for this is gonna be e, and e is non-ending number, just like pi. Example: the following limit given here without proof will be used in this 5.53. The following limit given here without proof will be used in section 5.5.3. The following limit given without proof. Following limit n to 8, e 1 over n minus 1, e 1 over n minus 1 equals to n equals to 1. So wait, what the fuck is wrong? E 1 over n minus 1, e 1 over n minus 1. So we have this number, we have this limit, we have this e, but power n. So for let's say it's fucking 2, it doesn't not matter. This is gonna be decreasing and it's gonna be multiplied by each other. I think it's gonna go down minus 1. So this number is gonna be, it's not gonna be, مش هيكون حاجة effective يعني مش هيكون effective, so it's not gonna be effective, so we're gonna end up with -1 all multiplied by n. Divergence sequence. Example: the sequence defined by an equals to n bar 2 belongs to. Okay, I'm gonna actually close the stream right now.